Why your microwave was a complete accident. It's 1945. You're an engineer working on top-secret radar technology during World War II. You're standing next to a magnetron, a device that shoots out invisible waves to detect enemy planes. Suddenly, you feel something strange in your pocket. The chocolate bar you saved for lunch has completely melted. This was the moment that would accidentally invent one of the most common appliances on the planet. Today, more than 90% of American homes own a microwave, heating up over 2 billion meals every single day. We modeled the entire thing to show you the hidden engineering behind microwaves, the wartime accident that started it all, and the invisible physics that make them work. In order to understand how microwaves work today, we need to go back to a time before anyone knew what they even were. It's the 1930s. War is brewing across Europe, and engineers are racing to build a system that can detect incoming enemy aircraft from miles away. The answer was radar. By shooting out invisible radio waves and measuring how long it took for them to bounce back, you could pinpoint the exact location of a plane in the sky. But early radar systems were weak. They used long radio waves, which spread out too much, and couldn't detect smaller objects. What they needed was a way to generate shorter, more focused waves. Microwaves. And in 1940, two British physicists, John Randall and Harry Boot, came up with this, the cavity magnetron. How magnetron works. Here's how it worked. Inside a sealed metal chamber, a heated cathode would release a stream of electrons. Surrounding the cathode was a ring-shaped anode with 8 precisely cut cavities cut into it. A powerful magnet was placed around the entire device, creating a magnetic field that ran through the chamber. When the electrons left the cathode, instead of flying straight to the anode, the magnetic field bent their path, sending them spinning in tight spirals. As they whipped past each of the 8 cavities, they caused the electrons inside the anode to oscillate at incredibly high frequencies. This generated microwaves at exactly 2.45 gigahertz, which were then channeled out of the device through a small antenna. The cavity magnetron was a wartime breakthrough. It allowed Allied forces to detect enemy aircraft, submarines, and ships with deadly accuracy. And it likely changed the outcome of the war. But it was about to change a lot more than that. After the war ended, an American company called Raytheon was tasked with mass-producing these magnetrons. One of their engineers, a self-taught inventor named Percy Spencer, was standing in front of an active magnetron one afternoon when he noticed something strange. The chocolate bar in his pocket had completely melted. But Spencer wasn't burned. Nothing else around him was hot. He realized the magnetron was somehow heating food directly. To test his theory, he sent out for a bag of popcorn kernels and placed them in front of the device. Within seconds, popcorn was flying everywhere across the lab. Next, he tried an egg. It exploded in a colleague's face. Spencer had stumbled onto something incredible. Microwaves weren't just for detecting planes. They could cook food. Why it works. But why? To understand this, you need to know one thing about water. Water molecules are polar, meaning one end has a slightly positive charge and the other has a slightly negative charge. When microwaves pass through food, they create a rapidly oscillating electric field, flipping direction 2.45 billion times per second. Every time the field flips, the water molecules inside the food try to align with it, flipping back and forth at the same frequency. This constant flipping causes the molecules to rub against each other, generating friction. And friction generates heat. Within seconds, the food cooks itself from the inside out, using nothing but its own water. It was completely different from any cooking method that came before it. No fire, no element, no flame, just invisible waves and the natural water in your food. With this discovery, Raytheon got to work building the world's first microwave oven. In 1947, they unveiled the Raider-Range. But it was nothing like the microwave you have today. It stood almost 6 feet tall. It weighed over 750 pounds. It required water cooling to keep the magnetron from overheating. And it cost the equivalent of $50,000 in today's money. Only restaurants, hotels, and ocean liners could afford one. For the next 2 decades, microwaves were considered industrial machines, not kitchen appliances. But to bring them into the home, engineers had to solve a series of huge problems. The first problem was containment. Microwaves are dangerous. If they leak out of the oven, they can heat human tissue just like they heat food, causing serious burns from the inside out. The solution had to be invisible to microwaves, but completely sealed. The body of the oven was made from solid metal, which naturally reflects microwaves back inside. But the door was a problem. You needed to see inside while it was running. Glass alone wouldn't block the waves. So engineers came up with a clever fix: a perforated metal mesh built into the door. Each hole in the mesh is smaller than the wavelength of a microwave, which is roughly 12 centimeters. Visible light, with a wavelength thousands of times smaller, passes through easily. But microwaves are too large to fit through the holes, and they bounce back inside the chamber every time. It was the perfect one-way filter. The next problem was even trickier. Because microwaves bounce around inside the oven, they form standing waves, areas where the waves overlap and amplify, and areas where they cancel out. This means some parts of your food would burn, while others stayed completely cold. To solve this, engineers added 2 key components. First, a rotating turntable that constantly moves the food through different parts of the wave pattern. Second, a stirrer, a small metal fan placed near the magnetron that spins as the oven runs. As the fan rotates, its metal blades reflect the incoming microwaves in different directions every fraction of a second, scattering them throughout the chamber. Together, these 2 systems ensure the food is exposed to microwaves from every possible angle, cooking it as evenly as possible. By the 1960s, the technology was there. But microwaves were still far too expensive for the average home. The breakthrough came in 1967, when a company called Amana, owned by Raytheon, released the Raider-Range countertop model. For the first time, a microwave was small enough to sit on a kitchen counter and cheap enough for a family to afford. It cost $495. Still expensive, but a fraction of the original. Sales exploded. By the late 1970s, microwave sales had surpassed gas stove sales in the U.S. By 1986, a quarter of all American homes owned one. By 2000, that number had reached over 90%. Today, microwaves are everywhere, and the engineering inside them is more refined than ever. When you press start, here's what happens. A high-voltage transformer steps up the household current from 120 volts to over 4,000 volts. This power feeds into the magnetron, which begins generating microwaves at exactly 2.45 gigahertz. The waves travel up a metal channel called a waveguide, which directs them into the cooking chamber. The stirrer scatters the waves in every direction. The turntable rotates your food through the wave pattern. The metal walls and mesh door keep the waves trapped inside. And within seconds, the water molecules in your food are flipping 2.45 billion times per second, generating the heat that cooks your meal. All from a piece of military hardware that an engineer once stood next to with a chocolate bar in his pocket. It's easy to take microwaves for granted now. They sit quietly in millions of kitchens, doing in seconds what used to take an hour over a stove. But behind that humble beige box is one of the strangest accidental inventions in modern history. A wartime weapon that learned how to make popcorn.